Hey everyone, this is Andrew, and welcome back to Mechie Learning. In this video, I'm going to be talking about PEM fasteners. They have a few different names. They're also called press-fit fasteners. Some people call them captives. Different names people call them, doesn't really matter. I call them PEM fasteners because the most popular brand that you'll probably come across is PEMs, made by this company called Penn Engineering. On their website's actually PEMnet, which is right there, PEMnet. And so these things are really neat and really useful. Now, while you're in college, a lot of the stuff you're actually taking is more focused on analysis stuff. So, you're taking courses in mechanics, dynamics, statics, fluid mechanics, thermodynamics, control systems, programming, manufacturing, statistical methods, whatever you're taking, mostly analytical stuff. They don't really touch on design stuff. And I didn't hear about these things until I did my senior project. And it was for a company, and I never heard of these things, and I was just putting, a screw with a washer and nuts everywhere, and the mechanical engineer that was helping us, kind of coaching us through the design process, said that, after he started working there, he kind of fell in love with these things. And they're really useful because they can reduce the total amount of loose parts that you actually have in your assembly. They're really cheap. They're like the same price as, regular hardware. They're easy to install, and it just kind of depends. You have to look up and, see which ones you exactly want and, where you're actually getting your parts made. But my point is that even though a lot of classes you take in school are analysis-based, chances are you're going to end up doing some kind of design work when you actually get a job. I'm not 100% sure in the actual statistics on what percentage of mechanical engineers end up in design, but I'm just kind of guessing that it's a lot. So these things are neat. I'll just kind of go on their website, which you'll become intimately familiar if you do a lot of design stuff. They have an animation section, and I'll just go into, I'll do standoffs. And this just shows you how they actually install these things and gives you an idea of what they are. So this is a standoff. So they have some kind of anvil thing here. They get your sheet metal, and they put the PEM on top, and then they actually press down with a punch, and the metal that was originally not there gets pressed around the fastener. So now your fastener is permanently embedded, and then you have a standoff embedded into your sheet metal. So generally, if you have a sheet metal assembly, instead of having a bunch of different things that you're screwing on, you have all these loose hardware, everything has like a washer and a nut, etc. You can just use these, and then, when you have your part made, you have your sheet metal part actually made, you can have them install these for you. So, I don't know, if you have an assembly that may have been 2 sheet metal pieces and 40 different types of fasteners, maybe you have some PCBs being mounted in it, and you have all these other components that need hardware, you might have had an assembly of 50 parts or something, with all this hardware. And now you're getting just 2 pieces of sheet metal. Now, you might have more because you have to actually screw stuff into these standoffs, and you have to thread into the nuts you're embedded into your sheet metal, but it'll bring down your total part count. And if you're just ordering a part, it'll get shipped to you with just, your 2 pieces of sheet metal with, your 30 or something PEMs. This is kind of an intense example, but... And then you just use screws and go into it. You don't have to worry about mounting your standoffs and using all these nuts and stuff everywhere. They're all embedded into your actual sheet metal. So going back to the homepage, you can see they have a bunch of different types. Bunch of different types of fasteners and stuff that you might need. And generally, I just kind of go on PEM fasteners. So they have these different brands of stuff that they sell. So I go into PEM fasteners, and then you can actually see... what they actually sell, and there's a huge variety. So let's just say I need nuts. I go into CAD/spec, and these are all the types. And I'm going to go back a page, go to the description of each product category, and this is actually going to show you what each one does. So if you want a nut, let's say this would be kind of your normal one, where it gets pressed in, and then, so this is pressed in here, and then this is the back side of the nut, and then you put, let's say you're mating 2 pieces of sheet metal. This is the one with the PEM in it. This is the one you're mating to it. You press them together, and then you screw in this side. It threads into the PEM, and then they're mated. You don't have to worry about, lining them up, putting the screw, and then having another nut. It's just already embedded into this piece of metal. This type here is, it actually gives some kind of length to it, and depending on your application, you might need that. As I say, they provide a barrier to protect threads against foreign matter, blah, blah, blah. And then, these are floating. So I know I'm kind of rambling on fast, but there's just kind of a lot to cover, and, you should just go and explore for yourself. But these floating ones are more interesting because they give you some wiggle room. As you can see here that, they can go in thin sheets. I forget what they qualify as thin sheets, and they permit up to 30 thousandths adjustment. So that means when you line up your pieces of sheet metal, nothing in life is perfect. So when you design something, there's always some kind of tolerance. So this allows you to be off in your tolerance by up to 30 thousandths. And these, the nut actually kind of wiggles around inside of this. So if I open this up, go in here, go in the unified for the English stuff. And I don't know how good of a picture it shows, but there's kind of like a air gap around. So this, this outside shell gets pressed into your sheet metal here. And then inside, this can, this is a cross section, so this can wiggle around by this much in all directions. So your tolerance can be off by a little bit, and you don't have to worry about it. So that can be a big concern. If you're putting just standard PEMs and stuff, PEM nuts everywhere, and let's say they're really far away, and you have a bunch of them. If something's off, some might not line up, and then you're kind of screwed. With hardware, it's a little looser because you might make your holes significantly bigger than you need them to be, just to take care of any misalignment issues. But with PEMs, you can't do that. But with these floating types, it gives you some wiggle room. So they're pretty neat. Just wanted to point them out. Flush mounts, they're going to be perfectly flush with your sheet metal, which as you can see here, sometimes you might not want something protruding up. As you can see, this can protrude up a good amount. If I go into their actual CAD stuff, go in the English system, and I'll just pick this one here. And they give dimensions for everything. So if I open this up, and this part gets pressed in, but this T1 dimension is actually going to be protruding up here above your sheet metal. So if I go for T1 down here, and that's 0.3 of an inch. So it depends on what you need in your design. But if for some reason you can't afford to have that protruding, then you're not going to want to use this type. You're going to want to go back. You're going to want to go to the flush type. Go to F, go to unified. Let's pick on one quickly here. And they're going to be flush. And you can see all the different dimensions here. These are, every single PEM is some kind of sheet thickness. So these can only be used in sheet metal to 60 to 91 thou. And, they give you a hole size that you have to mount it in with some tolerance and stuff. Let me go back to the general page. And now some of these can get a little more specific in their application. You have captives. Let's say, this is like a whole assembly. So this whole assembly is going to get press fit. And if I open this up, you can see that this part here, the bottom, this is what actually gets pressed in, the metal warps around. And so this little part gets held in. And then you have this protruding up. You have a spring that presses your actual screw away. So, if you want to have two parts that are mating and you want a thumb screw and you want the screws to be in there and you don't want them to come out every time you take apart your, whatever, this is a good option. Now, you could make assembly like this yourself, but this is kind of an easy, just buy it and forget about it kind of solution where you're just press fitting these into your sheet metal, and now you have captive everything. So this takes care of the nut, this takes care of the screw. Now it's a little different. Again, I'm getting into like the details here, but you need something to thread into for whatever you're threading into. Like you're going to have this is going to be in sheet metal, and there's going to be another part that's going to have threads. Otherwise, this is doing nothing. But it's a pretty simple little solution where if you need to have a captive threaded part, that's one thing you can do. And I'll show you some of their other products here. They have these micro PEMs. And I've never used these ones. I usually just use the regular PEM Fasteners. But, these get even smaller. So I'll just, sheet attachment. I'll just pick a random type. I don't know, I guess I'll just pick these. And I'll just pick the first one. So if I go into the pictures here, look up these dimensions. And so I kind of want to just get a rough size of how big this thing is. So, L is the length above the press fit part. Or, actually, sorry, it's not. L is the actual length of it's getting embedded. And then we have this part here. So let's scroll down. And we see that L dimension is... it's actually kind of amazing. It's 40 thou. It's 1 millimeter long. And the H is 71 thou. So that's really small. If you think of a number 4 screw, what is that? 0.12, or sorry, 0.112. I forget the number, but it's this is teeny. If I go back, and they have all these different, they have essentially nuts. They have different applications for these. They have screws. They have these inserts. And then I'll just go up here. They have these Atlas brand. Let's see, what are these? I've never used these ones either, but this is just they have a bunch of different products. I think they have some of the companies they've bought. They have these plastics components that they just bought this company or something or merged with them, and now they do them. They have a ton of different resources in here that go outside of just showing how they mount. They have this information. They show you how to design them. Or design your system to actually use them. And, one advantage that you have fewer parts to handle, fewer assembly steps, less assembly time. So those are kind of all related. If you have fewer parts, you're going to have fewer assembly steps and less assembly time. But that's really what these things are great for. Whoever's making your part, you just tell them, hey, put a PEM fastener, in this spot. And, you'll get your metal part shipped to you, your sheet metal part shipped to you with a lot of your hardware pressed in, which is great. They show some applications, and around here they show how they're actually inserted or drilled out. Go in literature, and they have just I haven't gone through a lot of this, but they just have boatloads of catalogs and information. This was particular to floating self-clinching fasteners, and they go into a lot more detail in terms of like the visuals here. It's kind of reads more like a book, whereas the website doesn't. It reads more like a website, as you can imagine. Yeah, so that's pretty much it. I just wanted to kind of show you potential future design students or people who have to do design projects in school that when you're handling sheet metal part assemblies, you don't have to just use standard hardware. You can use these PEMs. They I think somewhere they might have more detailed design stuff. You can go online and Google it. There's different things to take into account. Like you don't want to have these things too close to an edge because you are deforming the metal around these parts. You don't want to have them too close to a bend in your sheet metal. It depends when they're installed, before or after bends. Whoever's making your part will generally handle all that. But the certain distances you want to keep these things away from, because you could end up with deforming like a hole. You put them too close to a hole, you press these in, and now all of a sudden your hole gets warped a little bit. Or you have them close to a bend, and then you press them in, then you bend your part, and now your PEM's at an angle if they installed it in some order that wasn't perfect. And it depends on who's making your part. Generally, if you have someone reliable or some company they're going to look at your drawings, and if there's something wrong, they're going to call you and say like, hey, I was looking at this and I was about to do this, and then that's not going to work, or it's going to come out crappy. Because they want you to be happy with what you're paying you or your company's money for, because then you'll be more likely to use them. So hopefully you're working with someone who can help you out. But anyways, hope you found this video interesting. Leave a like if you enjoyed it. Subscribe for more stuff. And yeah, see you guys later. Bye.